Welcome, aspiring AI engineers, to day one of our brand new Pandas series. If you are someone who wants to get into Gen AI related technologies, learning about Pandas is crucial, and that is what we bring in this 10-day playlist. Okay, so over the next 10 days, we're going to learn various fundamental concepts about Pandas and what all you can do with it. So, as part of this series, we're going to have a fictional role play. And in this role play, let's say I just started a job at a fictional pizza chain called Pandas Pizzas. They sell everything from classic cheese slices to exotic gourmet pies, and business is booming. The problem? Their data is all over the place, and it's hard to find patterns or create helpful visualizations for management. My mentor suggested using Pandas to keep our data tidy, find trends, do quick math and stats, and handle the huge amount of information without breaking a sweat. So, in today's video, which is day one, we'll just set up our environment, which is always crucial to get started, and dive into some fundamental building blocks of Pandas, which is series and data frames. So, these are the topics which will be covered in today's video. First of all, we'll set up our environment, and this is crucial to get started working with Pandas. Secondly, we'll talk about a data structure in Pandas which is called series, and after that, we will get introduced to another data structure in Pandas which is called data frames. Okay, so these are the three high level things that we will be focusing on today. So let's get started with the first aspect, which is setting up our environment. Now, before we go ahead and install Pandas, you may have this question: why Pandas in the first place? Let me give you two advantages or two angles from which we can think about this. First of all, the business aspect. Let's say Panda Pizza's executives want to see which pizzas sell best, which toppings are profitable, and how to plan their ingredients. Without a solid data analysis tool, we'd be lost in spreadsheets. With Pandas, we can centralize everything, run quick stats, and eventually build fancy charts. Now, the second angle. When it comes to the day to day operations or the technicalities, if you use Pandas, it'll help you tidy your data, keep everything consistent, rows and columns. Secondly, it supports easy transformations such as filtering for data, sorting, cleaning messy data quickly, etc. And Pandas help you to handle thousands or even millions of rows without manually rummaging through spreadsheets. And finally, the integration aspect is also there. If you use Pandas, this works seamlessly with other Python libraries such as NumPy, Matplotlib, etc. So let's get started and set up our environment and import Pandas. Now, coming to the setup, you can either access colab.research.google.com. So if you do that, you'll get to this screen and you can create a new notebook. So this is on the cloud, so the setup is quite simple, and then you will get something like this. Let it just load, and over here you can start importing Pandas. As we've discussed, Pandas is a library which gives you a lot of functions which you can right away use without building everything from scratch. And it's extremely useful to deal with huge amounts of data. So we will see that in detail in today's video as well as in the coming videos in this playlist. But over here you can see I have opened a Google Colab notebook. So this is a IPYNB file, which is an interactive Python notebook. Okay, and over here you can say import Pandas as PD. Okay, and then you can click over here to run this, or you can click Shift Enter, and you can see it's running. So over here, first this is going to connect to some resources. You'll get some compute and memory, etc., allocated over here. And once the connection is done, you will see that this will successfully execute. So let's give it some time. So you can see over here, this has been done. You have a tick mark over here. So the connection is established, and you can see that this line of code has run. So you can start using it over here. Okay. Now again, let's just write print hello over here to see that it's actually working. So you can execute Python code over here, and it's block by block. Okay. So that's the advantage of a interactive Python notebook. Now this is one way. Now if you want to get started quickly without spending much time in setup, then you could do it this way. Or instead of Google Colapse, you can use a Jupyter notebook locally on your system. Now, again, the preferred way that I would go with is that you can create a .ipynb or an interactive Python notebook file in VS Code itself, and then you can do the same thing that we are doing over here in VS Code. So let's go ahead and see how we can do that, and let's also learn about something interesting, which is just a good practice, which is about creating a virtual environment before you go ahead and install various dependencies, etc., to be able to use Pandas and to work with it. Like, you may need to install some things, but again, don't worry about that. We'll see that in detail as we get there. But yeah, you would want to do some installations, etc. If you do that in a virtual environment, whatever you're installing would be in that environment, so it will not be applied globally to your system. So it's a good practice. So let's go ahead and see how we do that. Now again, remember, the way that we are going to do this first is that we'll create a folder. So you can choose where you want to store your .ipynb files. Okay, so we'll have a folder where we will have these files to play with, and inside that folder we will create a virtual environment where we will store all the dependencies, etc. Okay, so let's dive in. So I have created a folder in my projects folder where I store all my projects on my laptop. So let me go ahead and open that in VS Code. So you can see that I have opened this folder, Pandas full tutorial, in VS Code. Now before you proceed, just ensure that you have Python in your system. Okay, now to ensure that you have Python on your system, you can just open a terminal, and over here you can type Python version. Okay, so you can see I have Python 3.12.7. So you should be getting something like this, which would indicate that you have Python installed on your system. And if you don't have that, please go ahead and install Python. So once you have done that and you are in the folder where you want to work on your interactive Python notebook, let's first go ahead and create a virtual environment. And for that, I'll use the command. So I'll say Python -m venv for virtual environment. And let me just call this virtual environment Pandas tut. Okay. And you can see that I have created this virtual environment. So over here you have Pandas tut inside this folder. Now what we are going to do is we will go ahead and activate this virtual environment. And if you're on a Mac, the command for that is source, and then you have the name of the virtual environment, which in this case is Pandas tut bin, and then you have activate. Okay, so once you do that, you can see that over here I get Pandas tut over here, which indicates that this virtual environment has been activated. Now if you are on a Windows machine, in the command prompt or PowerShell, you can just type Pandas tut, and then you have a /scripts/activate. So that's the command. Let me just put it on the screen as well. So that is how you can activate the virtual environment on Windows. Okay. Now you can see that the virtual environment has been activated, and now let's go ahead and install all the dependencies. Again, the benefit of having a virtual environment is that it will isolate all the dependencies for this particular project. Again, you don't need that technically for this series, but it is just a good practice. So it's always good to learn something new. So we have created Pandas tut virtual environment, and we have activated it over here. Now let's go ahead and install the dependencies that we need for this particular project. So the first dependency would be to install Jupyter Notebook because we want .ipynb files over here, right? So let's go ahead and do that. And the command for that is pip install Jupyter. Okay, so let's do that. So I have done pip install Jupyter, and we are installing this for this particular project. Now let's go ahead and open the command palette. And if you're on a Mac, you can just do Command Shift P. Okay, so you can see that it brings up the command palette over here, and then you have to select Python select interpreter over here. Okay, and once you do that, you need to select your virtual environment, which is in this case Pandas Studio. So I've selected that over here. All right, and now it's time to go ahead and create our first Python notebook. So let me just call it day1.ipynb. Okay, and you can see that we have our first notebook over here. Now again, it's pretty similar to what we have seen in Google Colab. So over here also I can write code. For example, let me close this, and you can see that over here I can say print hello, and I can either click over here or I can do shift enter. Okay, now it's saying over here select a kernel. So let's do that. So I'm clicking Python environments over here, and I have to select Pandas Qt over here, which is our environment, or which is our virtual environment which we had created. And after that, you can see that this is activated. Okay, so yes, let's go ahead and run this now, and you can see that you get hello over here. And with that, we are done with our setup, which was the first part for this video. So quickly recapping, you can either just go to Google Colab, and then you can open a new notebook and you can start working on that. Okay, so you can import Pandas and you can start working. So that's your setup. It's quite easy. Or if you want to do it locally, you can do it in multiple ways. You can do it with a traditional Jupyter notebook, or if you want, you can get a Jupyter notebook in VS Code as well. So that's what we have seen over here. Now, working in this way in VS Code is beneficial when you're working on multiple projects. So that's why I think this is a good way to get started with this. So the steps that you have to take over here is you have to create a new folder, and then you have to open VS Code, and then in that folder you have to create a virtual environment. So we have seen the command for that, and then you have to activate your virtual environment and install Jupyter Notebook. Okay, and then it will ask you to select the kernel. So again, we have seen how you have to do that. And once you're done with that, you will get this option over here. You can see that you can have code blocks, and you can write Python code in these code blocks and execute it. So that is our setup. So we are done with our setup, and we can get started by importing the Pandas library. Now Pandas is a library, and again, the benefit of using libraries is that they provide you with ready to use functions which you don't need to write from scratch. So Pandas makes working with large sets of data very, very easy. So let's go ahead and explore various facets of working with Pandas as we go on in this series. Okay, now to start with, import Pandas as PD. Okay, so again, we are just giving it a name. Now you can see that over here there is this squiggly line over here, which is because Pandas has not been imported. Okay, now in Google Colabs it was already there, like we could directly run this command without any error. But over here, before you can run this, you'll have to install Pandas. So open your terminal and then you can say pip install Pandas. Okay, and then you can run it. So you can see we are installing Pandas, and once you're done with this, you can go ahead and import Pandas over here, and you can see that it's working. Okay, so we have successfully imported Pandas. All right, so far we have successfully installed Pandas, and we have also imported this library. Okay, so we are calling it PD over here. Now let's get started with the very important data structure in Pandas, which is called a series. Okay, so in Pandas, a series is just like a 1D labeled array. Think of it as a single column of data, like a list of pizza toppings or daily sales figures. Each data point has an index or a label and a value. Now let's get started and let's take an example to understand this better. Let's say you have a list and let's call it toppings list. Okay. And let's say this is equal to pepperoni, like you may have pepperoni as a topping, and you could have mushrooms, and another topping could be extra cheese, and maybe another topping can be sausages. All right. So you have this list over here. Now let's convert this into a series in Pandas. And let me call the series toppings. Okay. Now the way that we can convert this list over here into a series in Pandas is by doing pd dot and then you have series. Okay. So you get the suggestion over here, pd dot series, and then you have to pass in the data. So that would be toppings list in our case. So now we have converted this list into a series, and let's also see how it looks. And for that, I'll write over here series toppings. Okay. Now let's run this block over here. And you can see that you have pepperoni, mushrooms, extra cheese, and sausages. And you can see that every value has an index. Now you may say that this is also available in a list in Python, which is right. But the thing is that in series, you can not only have these zero based indexing values over here, but you can also have labels for it. Okay. And again, it's always useful to have labels because they are meaningful and you can query things based on labels. So to understand that, let's do one more code snippet over here. And let's say we want to mark these toppings as T1, T2, T3, and T4. Okay. And for that, you can just do series toppings, which is the series that we have created. So you can say series toppings dot index. Okay. And this is equal to, and then you can just pass in a list of the labels that you want for these 4 data points. So in this case, let's call it T1, and then we have T2, and then we have T3 and T4. Okay. Now let's also go ahead and take a look at how our series looks after we do this. So let's go ahead and execute this block. So you can see that earlier, notice we had 0, 1, 2, 3 as the labels or the indexes in this case. But now we were able to give labels to these values. So the label T1 corresponds to pepperoni, and then the label T2 is for mushrooms, T3 is for extra cheese, and T4 is for sausages. Now you can query things based on these labels. So let's also see that. So again, series toppings is the name of the series that we've created. And then over here, you can just say T1. Okay. And let's run this. And when you do that, you can see that you get pepperoni, which is what you have over here, right? So in this way, it's easy to work with series rather than lists because you can give them meaningful labels, and then we can always easily relate with those things, and it's much easier to work with that rather than if it was zero based index. You could get the same thing by doing series toppings at 0. Like let's do this once more. So I'm just copying this over here and let me paste that over here and we run it. So again, the labels are indexes over here, and you could query something by saying, let's say series toppings at index 1. Okay. So if you run this, you'll get mushrooms because at 1 you have mushrooms. But then this is difficult to remember, right? So T1, T2, T3 may be meaningful things in your shop. Like T1 could be the most ordered topping, or T2 could be the second most ordered topping, etc. So this is another advantage of series. Series now series is just an introduction to a much more powerful data structure in Pandas, which is data frames, because typically you'll not have data just like this, but you will have data like a table, right? And in those scenarios, we are going to use data frames. So let's get started with that. All right. So we have understood what series are in Pandas. Let's now get started with data frames. And again, we're just getting introduced to this. We will revisit data frames in greater detail in the next video in this playlist. Okay. So to get started with, you can think of data frames like a 2D table. Think of rows and columns, similar to an Excel spreadsheet, but with superpowers. Each column is essentially a series. Okay. So again, think of it as rows and columns, and every column in a data frame is a series. And what is a series? We have already discussed what a series is over here. Okay. So every column in a data frame is a series in itself, but all the columns share the same row labels. All right, now enough of theory. Let's get started with an example to understand this in greater detail. And we will load big sets of data in the future videos in this playlist. But over here, I'm just going to take a key value pair and a normal dictionary in Python, and let's convert that to a data frame to get started with this data structure in Pandas. So let's say I have sales data, and this is going to be a key, and this is going to be a dictionary. Okay. And I have toppings, which is what we had for the series, right? So I have topping over here, and let me just copy the toppings that we had previously over here. So that was pepperoni, mushroom, extra cheese, and sausages. Okay. So I'm going to copy this over here. So that's the value over here for toppings. And then I have, let's say, slice price. Okay. And the value for this is going to be, let's say, 2.5, and we have 2, and again let's say we have 2.5, and let's say we have 3. Okay. So for each of these toppings, these are the prices for a slice of a pizza with that particular topping. And then let's say I also have quantity sold. Okay. It could be in a day or so, but again, we're not concerned with that. We're just getting an example to get started with data frames. So let's say I have 50, I have 20, I have 10, and I have 25 as the quantity sold. Okay. So this is our dictionary over here. And let's now go ahead and convert this dictionary into a data frame, which is again a very powerful data structure in Pandas. And the way that we are going to do this is, we are going to give our data frame a name. So let's call it DF sales. Okay. And this is going to equal PD dot data frame. And remember, PD is how we imported Pandas over here. Okay. DF underscore sales is going to equal PD dot data frame, and then you just need to pass to it the data, which in this case is sales data. So let's pass it over here, and that's it. In this way, we have created DF underscore sales, which is a data frame. And let's also see how it looks. So I'm just writing DF underscore sales over here so that we can see how it looks. You can either print it or you can just type the name over here. Now let's run this block of code, and you can see that you have your data frame over here. Notice that topping, slice price, and quantity sold are automatically taken as the labels for columns, and you have 0, 1, 2, and 3 as the labels for the rows. Now we can change these. We will see that in a moment. So over here we have our first data frame. Now, a few things that may come to your mind is, why have data frames at all if they are just 2D arrays? Why not just have a 2D array in Python, right? Or a 2D list in Python? The reason for that is that data frames are smarter. They can keep labels for both rows and columns. Okay. You can see that Pandas automatically assigns rows indices 0, 1, 2, 3, etc. But we can change this. So that is one reason why data frames are better to work with data than just 2D lists. Another reason is that you can apply tons of built-in functions such as .mean, .sum, .describe, etc. for quick stats on a data frame, and we will just get a taste of it in this video, but we will dive deeper into it in future videos in this playlist. And also another benefit of data frames is that you can seamlessly merge one data frame with another data frame. You can filter them and you can reshape them for analysis. So data frames are powerful because they support label-based indexing. They support rich data types. Columns can be numeric, text, dates, or more complex objects, and they are easy to merge. You can easily merge one data frame with another data frame, and then you have a lot of built-in analytics which you can easily use when you're using a data frame. Okay, so again, we have talked about a lot of things. Now, let's see a few things in action. First of all, let's go ahead and see how we can change the label of the rows over here, because we have mentioned that that is one of the primary reasons why data frames is so powerful when we compare it with just a 2D list. So I have this data frame over here, which is df underscore sales, and let's say I want to change these labels to something like, let's say, to one, topping 1, topping 2, topping 3, and topping 4. Okay, so you can change it to anything you want, but we are just taking an example. So one way to do that is I can say df underscore sales dot index is equal to, and then you can just give a list of the labels that you want to give for these 4 rows. And in my case, I want to have it as T1 and T2 and T3 and T4. Okay. Now let's go ahead and take a look at our data frame, and let's run this block of code. And you can see that the labels have been changed. Okay. Now the reason why meaningful labels are so powerful is that we can easily relate to it. Now, if you want to know how many quantity of slices was sold on a particular day, which had my second best topping, which I mark as T2, so I would want this 20 over here, and you can use something called dot .loc to easily locate that. So over here I could say df underscore sales dot .loc, and then I can just give the row and column name. So the row name over here would be T2, and the column name would be quantity sold, right? And then you can see that if you run this, it's working. So again, let me just print this out, and you can see that I'm getting 20 over here, which is this 20. Okay, so you can see that providing meaningful labels to data is very powerful, and we will see more of this .loc etc. in future videos. But over here, I'm just trying to show you that data frames are in fact powerful and they are useful. So we're just getting introduced to data frames. Now, I had also previously mentioned that data frames come with a lot of built-in functions. So let's just see a few of them to get ourselves again introduced to data frames. So we have our data frame, which is df underscore sales, and let's say I want to print the mean of the quantity sold. Okay, so I can do that easily over here. I can just say df sales, and the column over here would be quantity sold, and I want the mean of this, right? So dot mean, and if I print that, you will see that it gives me the mean of this particular column. So you can see I've got 26.25 as the mean of this. Okay, so let's also find the sum of these values, which would be, again, you can use the dot sum function. So I can say df sales, and again the column is quantity sold, and I can say dot sum. Okay, so this would give me the sum. Again, let me print it, and when you run this, you'll get 105 as the sum of these values. Is it right? 50 plus 20 plus 10 is 80, and 80 plus 25 is 105, and 105 divided by 4 is indeed 26.25, which is the mean. So you can see that using data frames gives you all these powerful built-in functions which you can directly go ahead and use. Now again, let's also see one more interesting thing. You could do df underscore sales dot describe. Okay, so when you do that, let's see what happens. So you can see that you get all the numeric columns over here, slice price and quantity sold, which are these two columns. Okay, and then you have the count. We have 4 rows in each of these. We have the mean. Again, remember we calculated this a few blocks before. 26.25 was the mean. So that's what we have over here. You have the minimum value, you have the standard deviation, etc. So you have various things, and I think these things are over here are quartiles. Okay, now again, don't worry about that, we'll discuss this in greater detail probably in future videos. But over here, all that I want to say is that you can think of data frames as 2D lists but with superpowers. So we have got ourselves introduced to two data structures in Pandas in this video, which is series and data frames. Now, before we end this video, let me also quickly introduce one more interesting thing about data frames. So we have this particular data frame over here, df underscore sales. Now let me again quickly print that over here so that we can visualize it, or let me just say df sales. So this is how it looks like, right? Now you can also do df underscore sales dot d types. Okay, and let's print this. So if you print this, notice that you get the type for every column. Topping is an object, slice price is a float, and quantity sold is an int. Okay, now let me again quickly copy the code which we had used to create our data frame. So that's over here. Okay, and let me just paste it over here at itself. I could run it there, but again, because we have this, I just want to compare something with this. So I'm pasting this data over here again, and over here, let me change one of the slice prices to a string, and let's see what happens. So it's supposed to be a number, but let's say somebody by mistake entered a string over here. Now if I do the same thing over here, which is print df underscore sales d type, let's see what happens. And you can see that slice price now is of type object. Okay, so it ensures that all the types of the data in a column are the same, and because these two are floating point numbers, you have decimal values, but this is a string. So that's why it has converted all of these into an object. And if you see the type for a column which is supposed to be a floating point value or a number is coming as an object, it gives you an indication that probably you have to clean the data or something is wrong in the data field in that column. Again, another powerful feature of data frames, and one more reason why data frames are so much smarter than just 2D lists. Alright, so that's it for this video. We have got our environment set up. We have got introduced to two powerful data structures in Pandas, which is series and data frames. And in the following days, we will be diving deeper into Pandas. Now that we have a foundation, we know how to set up Pandas, and we have grasped series and data frames. What's next? On day 2, we'll get more hands-on with actual data files. We'll create data frames from different sources: CSV for daily orders, Excel for advanced product details, and Parquet files from our new forecasting system, and even a small dictionary-based data for promotional codes. Then we learn how to inspect and do a quick health check using functions such as .head, .tail, .info, and .describe. This is crucial to get hands-on with Pandas, which every aspiring AI ML engineer has to be. So for all of this and more, see you in the next video and in the following videos in this series.